Okay, so here's our second test review warm-up. We're going to pause the video here. You try these 3 problems, and then I will show you the answers. So for number 1, before I do anything, I'm going to simplify each part of the numerator with divided by 2. So that's 1/2 e to the x plus 5 over 2. So now when I go to do my antiderivative, the 1/2 carries down. On your formula sheet on the test, the antiderivative of e to the x is e to the x plus the 5 over 2, then gets the x from 0 to 2. So now we're going to plug in the top number. Minus the bottom number. And simplifying, these 2's can cancel, so we're left with 1/2 e squared plus 5 minus that 0. E to the 0 is 1, so that's just minus 1/2. So the only pieces then that I can simplify is the 5 minus 1/2. And that is 9 over 2. So this is our final exact answer. Okay, so now for number 2. We have cosine of 2x. So since the rule is just cosine of x in our formulas, we have to do some U-substitution for number 2. So I'm going to make the 2x my u. And I can't mix variables, so I have to eliminate this dx. So I'm going to take the derivative of u and manipulate that around so that I have the dx by itself. So now I can replace dx with du over 2. Before I do the antiderivative, I'm going to take my coefficient here of this 1/2, put that in the front. And now for the antiderivative, the coefficient carries down. The antiderivative of cosine is sine. There's no numbers on my integral, so I'm going to do plus c. And then as a last step, I'm going to plug the u back in. And this is our final answer. So 3 is going to be very similar. Let me get some space to do 3. So for 3, I'm going to say that the u is 6x. So we have the integral of negative sine of u dx. I have to take the derivative of u, and I'm looking to replace dx. So if I multiply dx to the right and divide by 6, I can replace dx with du over 6. But there's a 1 coefficient here, so I'm going to make this negative 1/6 sine of u du. So now for the antiderivative, you look at the formulas, negative of sine u has an antiderivative of cosine. Bring down the 1/6. Plus c because there are no numbers on our integral. And then the last step is to replace the u with what we originally said u was in the beginning. Okay, so the rest of the test review is all about finding the antiderivatives, and on part 1 here, get some space, I have to show my work because it says use the fundamental theorem of calculus. So first I'm going to find the antiderivative by doing the power rule. So I bring down the coefficient, add 1 to my exponent over the exponent. The 5 becomes 5x, and I want to evaluate that from 0 to 3. Before I plug in the numbers, I can simplify here. And now that I have a simplified antiderivative, we're going to plug in the top number from our integral, which was 3. Minus, and then plug in 0. So all of this is 0. And then in your calculator, this is going to be 2 times 27 minus 15, and we get an answer of 39. Okay, so for number 2, if we look back at our formula, the antiderivative of sine x is negative cosine x. So we've got negative cosine x from 0 to 2 pi. So we're going to plug in the top number, minus, plug in the bottom number. And because it's 2 pi, if you're going to evaluate that with your calculator, make sure you're in radian mode. So cosine of 2 pi is 1, but I have to bring down that negative coefficient. Minus a negative is plus, and then cosine of 0 is 1. So negative 1 plus 1 is 0 as an answer. For 3, I cannot do the antiderivative yet because of the quantity squared. So I have to simplify the integral by multiplying the two binomials together. So x to the third times x to the third is x to the sixth. So you can FOIL, box method, whatever your preference of multiplying is. Now I can do the power rule. So I'm going to add 1 to my exponent divided by the exponent. For each term. And then we can plug in the 1 and the negative 2. So we get 1/7 plus, oh, these can reduce, 1/2 plus 1 minus, and then it's negative 2 to the 7th divided by 7 plus negative 2 to the 4th over 2 plus negative 2. And I would use your calculator to simplify each piece individually. So this first one in your calculator, you should get 23 over 14 minus. And then for the second part, because of all these negatives, I'm actually going to do each one by hand. So negative 2 to the 7th is negative 128. Negative 2 to the 4th is positive 16 over 2, and then minus 2. So if we do negative 128 divided by 7, And then 16 over 2 is 8, so plus 8 minus 2. We're going to get another fraction. And this last, so we're going to get 23, oops, where's my pen? 23 over 14 minus 300 over 7. And then simplifying to your answer. Hopefully I calculated this right. I'm in my car working on the video while I wait for a doctor's appointment for my son. Hopefully this is right. Now, let's assume it's not, because I can't check on the next page. What you can do on the test is if you show your antiderivative, you show the numbers plugged in, and then let's say something happens and this number is not right. I will give you partial credit. It would probably be like minus 1/2. You're showing all the work, then something calculator-wise down here is going wrong. Okay, so now I've revealed number 4. Let's do that one. Before we can do the antiderivative, I'm going to change the radical to a 1/2 power. So now we can bring down the coefficient, add 1 to the exponent divided by the exponent. We don't like to divide by this fraction, so instead we'll multiply by the reciprocal. And because we can multiply these coefficients together, the 3 divided by 3 is 1. So our final antiderivative is 2x to the 3/2 from 25 to 36. So we can plug in the 36 minus plug in the 25. When you type this in your calculator, you have to put parentheses around your exponents to make sure you get the right final answer. Okay, and lastly on this page, number 5, do the power rule. I can simplify this one. And now we can plug in 2. So 2 to the 3rd over 3 minus 2 times 2 squared minus 3 times 2 minus, and then plug in the -1. And calculate that to get your final answer. Okay, for 6, we can do the power rule. From -1 to 1. This can simplify to 2. Plug in the 1, plug in the -1, and simplify. So let's see. That's going to be 2 times 1 to the 4th minus 3 over 2 times 1 squared minus 1. All subtract. Okay, so this is going to be 2 minus 3/2 minus 1 minus, and then -1 to the 4th is still +1. And simplifying all of this, we get -2 as our answer. Okay, 7's a quick one. The antiderivative of 2 is 2. is 2x. Evaluating that from -5 to 3. So I'm going to plug in 3 minus plug in -5. And we get 16. Okay, for 8, I cannot do the antiderivative the way the problem is written. We have a variable in the denominator. So we have to make this 5x to the -6th. So now I can do my power rule, bring down the 5, add 1 to the exponent, divided by the exponent. 5 divided by -5 is -1. And then this can move back to the denominator. And then plugging in my numbers. We get -1 divided by -1, so that's +1, minus, and then the -2 to the 5th is going to is still negative. So this negative divided by this negative are positive, and 2 to the 5th is 32. So our answer is 31 out of 32. Okay, now for 9, I'm going to first simplify by dividing each part of the numerator by the square root of x. So, but instead of the square root of x, I'm going to think of it as x to the 1/2. Because now I can simplify this fraction by subtracting my exponents. So 1 minus 1/2 gives me x to the 1/2. And then I don't want a variable in the denominator, so I'll make that a -1/2. So now from here we can do the power rule. Add 1 to the exponent over the exponent. -1/2 plus 1 is 1/2. And then from 1 to 4. Instead of dividing by those fractions, we're going to multiply by the reciprocal. And I can multiply the 3 and the 2. From 1 to 4. So now we can plug in 4 and plug in 1 and subtract, and you will get your answer. When you do these exponents in the calculator, you have to type it as, and this is how I would type it in the calculator, parenthesis, 2/3, parenthesis, 4 to the parenthesis 3 over 2. So you need all those different parentheses to help you get the order of operations correct. Same thing with the 6 times 4 to the parenthesis 1/2. Okay, so part 2 of your test review, all of these are indefinite intervals. So every single answer is going to have a plus c. So the constant of 7, the antiderivative is 7x plus c. For number 2, we're going to do each term individually, add 1 to the exponent divided by the exponent. The constant becomes 5x plus c. For number 3, there's that exponent of 1. So that add 1, we get 2, divide by the new exponent. We should simplify. This 4 divided by 2 is 2. For number 4, the 7 is going to carry over. X add 1 to the exponent divided by the exponent. Okay, for 5, we can't do anything yet. First, we have to make this an exponent of 1/5. Now we can add 1. So let's see, 1/5 plus 1 is 6/5. So we get x to the 6/5 all divided by 6/5. But instead of dividing by this fraction, we are going to multiply by the reciprocal. Okay, for 6, we have to make this a negative exponent. Now I can add 1 divided by the new exponent. And the only thing I'm going to fix is this x to the negative 2 can come back to the denominator. Okay, so for 7, we're going to do each term individually as the power rule. And the only thing I would simplify in your answer is this 4 divided by 2. So we get 5x to the 3rd over 3 minus 2x squared plus 3x plus c. And now for these last 3 problems, 8, 9, and 10, we have a function inside another exponent. So all 3 of these problems will need U-substitution. And that is the longer process where we have to pick the U. So we pick our U term based on whatever function is inside the other exponent, or U is whatever, if you take the derivative of it, you get the other term. So I'm going to replace the 4x plus 5 with U. So that's U to the 3rd, and I'm left with a 4 and a dx. So now, if I take the derivative of U, we get 4. So I have to replace at least this dx so that I'm not mixing variables, but if I can match the 4 from my derivative equation, that's fine as well. So if I multiply both sides by dx, we get du is 4 dx. Well, since this 4 dx matches this 4 dx, I can replace 4 dx with what it equals, which is du. So now I'm at a situation where I can do the power rule. We get u to the 4th over 4 plus c. But we didn't start with u in the beginning. We started with 4x plus 5. So I'm going to plug that back in. And that is our final answer for 8. Okay, so now for 9. I'm going to pick our u so that it is the term. When I take the derivative of it, I get the other. So for example, 6x squared gets me 12x, which is not here. But the derivative of 2x to the 3rd gives me 6x squared, which is this term. Plus, all of this binomial is inside another exponent. So our u is 2x to the 3rd plus 3x squared. So I'm going to replace that. And then we're left with 6x squared plus 6x and dx. So we need to replace all of this. So I'm going to take the derivative of u. I notice that this 6x squared plus 6x matches exactly. So if I multiply dx to the right-hand side, we get that du is 6x squared plus 6x dx. And that exactly matches this piece. So I can replace it with what it equals, which is du. Now I can do the power rule, add 1 to the exponent divided by the exponent, and put back in the u we started with. Okay, last but not least for 10, the inside function, which is 4x to the third minus 2. So that's u to the fourth x squared dx. So now I'm going to take my derivative. And I notice from the x squared dx, I have the x squared. So we can multiply the dx to the right-hand side. But I only want to match x squared dx. So we're going to divide both sides by 12. So we get du over 12 is x squared dx. Well, there's a 1 in front of the du. So this 1/12 I can move to the front and make that a coefficient. And now I can do the power rule, bring down the coefficient, add 1 to the exponent divided by the exponent. We'll make our denominator 60, that's 12 times 5. Replace our u to the fifth plus c, and that's our final answer.